Okay, so this is the last half of the screencast for Shani and the people who are gone in H period. So we went over these questions already, so we'll start with E. So first step, we'll look at the graph, right? We'll try to figure out the left side limit, the right side limit, and then see if the limit exists. So first let's do the left side limit. So this is approaching 0 from which side?
The left.
The left, because I just said it, my bad. And so we're going from numbers that are below it, going from the negative side, meaning we're going to be coming this way.
To 0.
And let's see, what does it seem like we're approaching?
0.
As x is approaching 0, what is y approaching?
Negative infinity.
Negative infinity. So technically, this means the limit doesn't exist because infinity is this abstract concept, but whatever.
What do you write on here?
Negative infinity. That's what I wrote. Yeah. And if I want to do the right side limit, right, going from the positive side.
Negative infinity.
Interesting. Okay, so they both match. So does that mean that the limit as x approaches 0 is negative infinity?
No, because they
No.
don't exist.
Exactly. So even though these are both equal, meaning I wrote the same thing, they both do not exist, so meaning the actual limit itself cannot exist. Both are equal.
How do you know it does not exist?
So infinity, if you have a limit that's infinity, it doesn't exist. It's not one concrete number you can pin down. Infinity is this abstract concept where it just keeps going and going. It's not a single number. Both are equal, but does not exist. Therefore, limit does not exist. Okay, cool. So this is decreasing without bound. What do I mean when I say without bound?
It doesn't have an end.
Exactly, it doesn't have an end. Without bound doesn't have an end. So it's just going to be decreasing, decreasing, decreasing. Okay. And lastly, example F. Okay. So it's a lovely one.
What happened here?
So this is an oscillating function. What does oscillating mean?
It like goes up and down.
Yeah, it goes up and
I
down.
know. I just don't remember.
So we studied sine already. All right, so sine is a wave. What happens if you could like scrunch sine together?
Oh.
So it looks something like this.
But at the same time, it like widens out.
Right, so by scrunching part of it, it's kind of like a slinky, right? If you have a slinky,
that's
you
cool.
grab some of them, you put some of them closer together, the ones on the outside like get further apart. All right, so it's an oscillating function. So as it gets, so it starts with like really loopy and then it like comes in and then it goes across. Okay, oscillating. Cool. So what's the limit as we approach 0 from the left side? Like what does it look like we're approaching? Let's see. So here and here and here. Oh gosh.
You never touch 0 because x can never equal 0. You can't have 0 on the denominator.
Right, so that's an issue. So the limit, well, the actual function itself won't have a value there. But if I get really, 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 really close, if I really, really, really close to it, like if I get negative 100th, negative 1,000th, negative 1 millionth, like getting really, really close to x equals
They don't have a
0.
hole there? Wait, this is continuous though, so how do you like...
So, like, it turns into a limit not existing. Because as you get closer and closer, as you go from like negative 1 to negative half to negative a fourth, negative 100, like as you get closer and closer to 0, the value isn't approaching one single one. It keeps fluctuating up and down. So that's why it doesn't exist. Same way when you approach from the right side. So it's left. Same way when you approach from the right side. Right, as you get closer and closer to 0, like we go 1, 1, 1/2, like we keep oscillating back and forth. So like any little incremental change, I'm not actually approaching a single number. I'm just oscillating even more.
Oh.
So I'm actually not approaching a number. I'm not getting closer and closer. I am actually doing the opposite. It just gets further and further. I don't know. It just keeps going back and forth. It's not zeroing in on some number. So remember the zombie story, how we were cornering someone? Like, we can't corner this number. Like, there's not actually a value we're getting closer to. So what does this mean for our limit of the actual function? Exactly. It does not exist as well.
But technically, since you can't have a 0 on the denominator, so there would be no value.
There's
for
no
0.
function value there, but we could still have a limit.
Okay.
But I mean, we don't. But like theoretically, you can have.
Because
So up
the
here?
limit is, like if there's a hole in there.
So right here, for instance, we didn't have a function value, but we had a limit because it looked like we're approaching a single number.
Because it's theoretical. Okay.
The limit is like the prediction. All right. Why limits at a point do not exist? The limit of a function as x approaches a number does not exist if f of x approaches different values from left and right. So which examples would this correspond to? Which examples were we approaching different values from the left and right?
C and D.
C and D. Exactly. So this is kind of like a little cheat sheet, like helps you when you're going through your homework, like, okay, wait, does this remind me of something we did before? Like proves to you when limits do not exist. All right. If the function increases or decreases without bounds, so if it's approaching positive infinity or negative infinity from the left or right of the number in question, so this is exactly like E.
What about D?
Well, it's not approaching the same. Like it's not both increasing without bound or both decreasing without bound. And we already took into account the one that like
they're not going to the same number.
Right, if they're not going the same. D goes to the first one, E goes to this. And then if it oscillates between two fixed values, so this is example F. These are the cases when you have the limit will not exist.
Are we going to review this when we get back?
Yeah, I'll do a little review. Yep. All right, 2 more pages. We got this. Okay, so this whole thing up to here is supposed to be 1 day.
Well, we did like a fun homework.
I know, we did that. Yep, we did. Okay, and then this was like planned to be the second day. So recall, oh my god, I'm dying. Okay. You guys want to take like a 2-second break? I need water. So recall from lesson 1.3, limits can be used to describe end behavior. So from 1.3, so remember how we talked about like the limit as x approaches infinity, what's y approaching, right? The limit of f of x as x approaches infinity, so like the end behavior, that's from 1.3. And also I think we talked about this in 2.4 as well. Okay, so limits at infinity. So as x approaches infinity, as x approaches negative infinity, what's happening? So recall from lesson 2.4, you learned the following. If the limit as you approach from the left side and as you approach from the right side is positive or negative infinity, then you have a vertical asymptote there. If you are approaching a single number, right, as x approaches infinity, are you approaching like 2, like an actual number? That's what this B means, is it's like a number, not infinity, just a constant number. Then you have a horizontal asymptote.
So your x is infinity. Wait, okay, so x of like approaching A is like if you're approaching a number?
Yeah, approaching as x approaches a number A. If the y values are approaching positive, negative, infinity, that's where you'll have a vertical asymptote. But as x approaches infinity, are you approaching like a certain number? You guys want to show your laptop for like 2 secs? That'd be great. Okay. All right, so let's estimate each limit if it exists. So the limit as x goes to infinity of this function. So what's happening as we go to infinity? Let's see, as x goes to infinity, so that's going to be going this way. Am I approaching a certain number? Negative 3. Because I'm only looking at as x goes to infinity. Versus if x goes to negative infinity. Let's see, 1, 2, 3, 3 down.
What about the y part? So y is approaching 0.
Well, what do you mean the y is approaching 0?
No, like the going straight up, it's approaching 0.
Oh, at x equals 0, we have a vertical asymptote, but we're not finding the limit there. If I wanted to find the limit of 1 over x to the 4th minus 3 as x approaches 0, it's going to not exist because I have a vertical asymptote.
Oh, that's cool.
But like I'm not really caring about this middle part, remember? The end behavior only cares about what's happening, the ends. All right. Did we answer this question? It's also approaching -3.
Cool. I get it.
I guess I should probably like have shown you what I was talking about with Ariel. So here's this A character. Like if I have, as I approach it, if my limits are approaching positive, negative, infinity, then you know you have a vertical asymptote right there. Okay, this is at x equals A, so that's this one. And then the other one, just so you have it in your notes and so you understand, if like, this is like y equals b, if our function is like approaching it as we go to infinity, if we're like cutting off, just like what example A was. All right, let's check B. Yeah, sorry. It's a lot of stuff.
How do you make it?
No extra credit. Just do it.
Okay. So it's oscillated, so it does all the things.
Y equals sine x, and this oscillates. What kind of arrow was that? These screencasts are not going to be as fun to watch because there's no like bickering. Yeah, they oscillate. No, I'm good. Please no. The function stays between -1 and 1. So oscillates. So we don't actually have a limit as we approach infinity because it's like it keeps going up and down. Great. See, this isn't too bad. So all of these are end behavior. So, okay, let's break this down. So I see as I approach negative infinity, right? So as x approaches negative infinity, the end behavior on the left side, what am I approaching? -1. What about, what?
No.
What about as x approaches positive infinity? So I'm approaching positive infinity, which is that way. What am I approaching? 1. So this was where people had trouble because they would sit here and the first thing they see on this graph is like this vertical asymptote and they're like, oh my god, what's going on? Blah, blah, blah. Like, no. As x approaches the infinities, like as they go left, as they go right, what's the end behavior? Versus if I would ask for the limit, not at infinity, but instead for x equals 0, then this would not exist because that's where we have a vertical asymptote. So you have to be careful. When you are having x approaching infinity, you have to look at the ends, not like the middle. So you're looking where the ends of the graph are. Not too bad. All right, let's do the next one. This isn't too bad. All right, and then D, last one. So as we approach negative infinity, so as I go to the left, what am I approaching in my y value? 0. As I approach my right side, it's the best 0 of my life. I'm just going to be done. There's no more. As I approach infinity from the right side, what's going on? Am I approaching a number?
Well, how do we know if it'll level out?
I mean, okay. First, this is e to the x, so you do know that. If it was a harder question, like you'd have to have the whole graph, you'd have to like zoom out. I have to show you all the turning points. Remember turning points?
Yeah.
I have to show you all the turning points, and then once you figure out those turning points, whatever they're doing at the ends, that's what they're going to be doing. Also, if it's a polynomial, we went through leading term test. So if you have something that's like x squared, x to the 4th, x to the 6th, like what's the end behavior? Like I'm showing you what the end behavior would be. Versus like negative x squared, x cubed, looks like this, x to the 4th, x to the 5th, x to the 6th, right? So we went through that stuff with the leading term test. So that's how you would like know if it's a polynomial. E to the x, exponential functions, you would have to know.
Cool.
Okay, and then so we see technically the limit does not exist because it's always increasing.
Cool. If we just wrote infinity,
Yeah, that's fine. So this is the homework. I mean, you guys have like 20 minutes. You can work on this, work on other stuff. That's it.